is random forest. Actually, till now, what I did first, I connected one session to explain the concept of the particular machine learning model. Then, after, we'll conduct another session to explain or to practice in the Python. But for the random forest, why I directly enter into the Python means random forest machine learning algorithm is extension of the decision tree. So random forest doesn't have any separate algorithm. Whatever the algorithm, whatever the concept in the decision tree, it builds the same. Random forest build on the same concepts and same root, same Gini index, same entropy, same calculations. Everything is same. So there is a small difference. What is that difference? We'll explain in this before going to the Python practice. Okay. Actually, for the linear regression, for the logistic regression, for the decision tree, for the PCA, uh, the way of building model, the way of we are using that concept, the way of algorithm, the way of calculations they are using to find the root nodes, to find the sigmoid function in logistic regression is the different. That's why uh, I explained each and every concept for those linear logistic every machine learning model. But random forest is on top of the decision tree. Actually, in decision tree, we already discussed about that. There might be a chance to go for the overfitting. That's the problem. Why? Because if decision tree, we can build decision tree entire tree. That is, for example, till leaf node, if without pruning, if we have taken leaf node, what will happen? So we will say the one particular way for the source to destination is there. Whenever we give new data point for the prediction, in that data point, whatever the data available in the training data, if it doesn't present in the new data point, what will happen? It will be confused to say whether it is the class 1, class 0, class 2. So we need to do pruning. What is the pruning? It will in decision tree. We will from the starting onwards. What we'll do? We'll take entire data set is the one. Then after we'll take the root. Then after we'll split till each leaf node. Pruning will go for the uh, by eliminating or by terminating the bottom of the tree. Bottom of the tree means there might be, for example, yeah, bottom of the tree means let's take this as example. What will happen here? We have take one condition. Here we have take some condition, but here it might be the condition. If we have pruning, for example, if we are eliminating the whatever the data nodes here in the bottom line, what will happen if we are considering this is the decision making node? If the data point have this point or this point or middle of this point, what will it say? This one belongs to this node. We won't expect, for example, let's take these are the 1 2 3 4 5 6 7 8 till 16. Okay, 1 2 3 4 5 6, like that. You can take, if it is 1, that is the belongs to this group. If it is 2, that is belong to this group. Let's see, if maybe whenever we give new data point, it have the 1.5. Does we able to say whether this 1.5 is belongs to this class, is 1.5 belongs to this one? No. So that is the some overfitting problems. Whenever train data, we already have that data. That's why it gives the high accuracy. But whenever test data, maybe if test data have the 1.5, like this, any other new data point, what will happen? Accuracy will go very slow. For that purpose, what we are doing, we are using some pruning technique in the decision tree. What it did, instead of going to the end of the tree, it will examine. For example, it will first take this is the class. For example, class B. These two are the decision nodes for this class 3. It will take like that. It will check the model performance. If the whenever we have taken model performance is the 90 accuracy in this one, for example, whenever we have taken this is the decision node, still we are getting 90%. Instead of taking this one, it will take this is the decision making node. What will happen at the time? So till, for example, 9 to 12. Previously, we considered this is a 1, 2, 3, like that one. This is the 9 to 10. Whatever the data point, if new data set comes, if the data point 9 to 12, what it say? It says this is the class B. Again, it will, by ignoring this one, that means by terminating this one, it will take this is the decision make node. It consider this is the decision make node. Again, it will calculate the model performance. If it is still 90%, what it did, it will terminate these entire splittings. It will consider this is the decision making node. In decision tree, we have the three types of nodes, three or four types. One is the root node, that is the this one. One is the root node. Then after that is the subnode. Subnode means these one. Then after we have the branches. Subnode are we call those are the branches. Then after decision making node, termination node. Termination or leaves are nothing but the below ones, which are the last line of the tree. End node of the tree, that is the leaves, and that means we can't split that node more than that. There is no chance to split more than that. That is the leaf or termination node. To finding decision making node, that is the important in decision tree. Why? Because if for example, here in the let's take this is the decision making node, we are able to see clearly if whatever the data point comes still here, these all are belongs to class B, these all are belongs to class D, these all are belongs to class C. So by visualizing, this is the tree. So this, let's take this is the decision making node. So if you have taken this one or this one, this one, we will get the same training accuracy. Same training accuracy 90%. But whenever going to the testing, when if you have taken this one, it gives the 90% accuracy and the test data set also. But if you have taken this one or this one, the accuracy will decreases. Why? Because here it says count. Particularly, it says, for example, here let's take this is the some node. Whenever it comes here, again it will check to satisfy these two conditions also. Why? Because here we are taking this is the decision making node. If this point is the 15, but if we have the data with 14.8 or 15.2, it doesn't know. Why? Because it doesn't take any condition like this one. For example, here what it takes, greater than or equal 13, less than or equal 14 is belongs to class C. So here we have taken that one. Whenever, if we consider this is the decision making node, let's consider this is the decision make node. What it says, if data point is equal 13, is equal 14, is equal 15, is equal 16, then only class C. Between numbers it won't consider. Did you understand? For example, let's take sometimes numerical data we won't get 1, 2, 3 like that one. 20, 24, 26, 27 like that. What will I have? Let's assume this is the 20, this is the 25, this is the 28, this is the 36. Whenever between points comes, we don't know whether it is belongs to which class. If we have taken this is the decision making node. If we consider this is the decision making node, what we'll do? Greater than or equal 20 or less than or equal 36, these data is belongs to class C. So that is the difference between the by taking decision node as this one, this layer, or decision making is that this layer. If we are not able to prune like this, what will happen? Our decision making, our decision tree model will become overfit. That is the main problem with the decision. Here we have the two types of pruning. One is the pre-pruning, second one is the post-pruning. Pre-pruning means we need to say, in the clustering you already know, we need to say how many clusters, how many patterns are presented in the data set with the name of K. If we give K is the 4 cluster, it divided into the entire data set into 4 groups. Just like we need to define first where will we get the decision tree. but it's not possible. Is it possible before building any tree, a third subnode or fourth branch will become a decision node? So it is very typical. So we need to go for the post pruning. Post pruning is after building entire data set, it will do like this one. A decision tree won't come like this. Sometimes it will go for the clumsy. So pruning also not that much easy. At that time, to solve that overfitting problem, this random forest comes highlighted. Forest means that is the tree is one tree. What is mean by forest? How many trees will available in the forest? Many number of trees are available in the forest. For example, what we'll do? Actually, we don't same. Let's take the k nearest neighbors. What we'll do? For example, if we have the only one tree, someone says, uh, someone come, do you know is this tree belongs to any group? If they ask, what we'll say? By seeing that tree, we don't know anything about the tree, so we can't say whether it is belongs to uh, which what is the name of that what is the psychological name or any name. But if we have the 100 trees, what we'll do? Based on the tree height, based on the leaf structure, based on the stem structure, at least we are not able to say name, but at least we are able to say these 10 trees are belongs to one group. These 10 trees are belongs to one group based on the height, stem structure, what are the fruits, what are the flowers, what are the leaf structure. Based on those characteristics of the tree, we are able to group into the one group. That is the concept we used in the random forest. So here, instead of making one decision tree, here we will use 10 or 100 decision tree based on the data set. For example, if we have the 5 features with 50,000 or 40,000 records, at least 1,000 records. Based on the 5 features, 1,000 records, we can't split into the 100. We can't make 100 trees. So based on the which type of data, what percent of data, how much of data does we have, based on that we will make decision trees. That's our based on our data. So if we have the some 5 lakhs, 6 lakhs records with 30 or 40 features, then we build, definitely we are able to build 100 decision trees. So decision tree is useful for the both regression and classification problems. So random forest also on the top of the decision tree. So it will also support both regression problems and classification problems. So that is the concept behind the random forest. So to overcome the decision tree problem, we sometimes we need to use random forest. Coming to the random forest. So it is also supervised learning algorithm. Uh, do you people remember? I already told you what is the supervised learning, what is the unsupervised learning. Anybody able to define what is the supervised learning algorithm? What is the difference between the supervised and unsupervised?
We will be not giving the trained output in unsupervised learning, whether we will be giving the trained output in the supervised learning.
Ah, Ranjit, what you are saying, your intuition is correct, but the way you are saying the terminology what you are used, that is the not correct. We'll say trained input means what means target. Actually, trained is different between the target. If we are able, our data has the label or target, that is the supervised learning. If our data set doesn't have label or target variable, that is the unsupervised learning. You know the difference between the training and target. Trained data means yeah. So it's not trained target. Which target is the target or ground truth variable, label variable, all are the dependent variable. All are the synonyms. If you for people to understand easily, these are the synonyms. All are saying about the same thing. Ground truth variable, label variable, dependent variable, or target variable. If the data set have the dependent or label or target or ground truth variable, that is the supervised learning. If data set doesn't have dependent or label or target or ground truth variables, if data set doesn't have these variable dependent variable, that is the unsupervised learning. These are the some small questions we need to face in interview. That's why I'm saying it again and again. Why? Because this is the main concept. Based on the supervised learning, based on the data, whether it is supervised learning, we'll go for the decision tree, random forest, logistic, linear, these things. If it is the unsupervised learning, we'll go for the recommendation engine, association rules, clustering, like that. So if interviewer feels, if you don't know the what is the difference between the supervised learning and unsupervised learning, he feels, if he don't know whether that is supervised learning or unsupervised learning, how can he build models? So that's why this it is not a big concept, but it is the basic idea we need to know. And that's it has the two variables. One is classification problem, other one is the regression problem. I already told you decision tree works for the regression classification problems. So random forest is top off on that. That's why it is also solve two types of problems. It is one of the most flexible and easy to use algorithm. It creates decision trees on the given data sample, get predictions for each tree, select best solution by means of the voting. It is also pretty good indicator of feature importance. For example, what we are doing means,
Ma'am, one thing I wanted to ask.
okay,
Ma'am, that target data is also known as the testing data, or it is the different one? You said,
target data. Target data means label one, Akash. For example, let's take, we have the image classification. We have
yeah,
the images of human beings. We have the only human beings. Let's take only human beings images. If you have only images, but you don't know whether it is girl, whether it is boy, whether it is children, whether it is old people,
yes,
but you have the all people's, that one. If you don't, what we call, based on the image, for each image, if we have the one label, that is the this image is belongs to girl, this image is belongs to boy, this image is belongs to children, this village is image is belongs to older women, this image is belongs to older men. If these are the labels, what are the label, older women, older men, boy, girl, these are the labels. If we know the label, what we'll do? So we'll observe some images which are girl. We observe some other images which are boys. We observe some images which are children. So based on that, we will get some idea. Whenever we have seen some other image, we will know, we are able to identify the label of that image. Why? Because we already know the some images with labels.
yes,
So whenever we see the image, we are able to identify whether it is the girl image, whether it is the boy image, whether it is the children image. That's, let's take
okay,
the same example of the different trees. We have the different trees images, but we don't know the what is the name of that tree. So the names what we are saying, that is the dependent variable or labeling variable or ground truth variable or target variable. Why I am repeating these four terminologies again and again means, whenever interviewer or some other person, mm, if he have the habit of using the label variable, but you learn with the name of target variable, whenever he pronounce label variable, you feel confused. What is this that label variable? We have the two variables, dependent, independent. Dependent is nothing but target. Where is this label? Where is this ground truth? That's why I am repeating those terminologies again and again. Okay? Don't
yes.
feel bored.
No,
So
ma'am.
yeah, these are the dependent yeah, these are the variables. Yeah. If trees, we don't know the names. we have the 100. So we have the trees images. We have observed 100 images. Whenever new image comes, we are able to say this image is belongs to some of the images which are presented on this 100 images. But we don't identify what is the name of this image. Why? Because we don't have the label data. We have only images. We don't have any label, whether it is the neem tree, whether it is marigold tree, whether it is the jasmine tree. We don't have whether it is mango tree, like that. That is the ground truth. Ground truth means ground truth or target or label means we have the some information which is belongs to particular group, particular domain or particular thing. That is the dependent variable. That is the whenever we have that particular labeling for the data. Let's take a house price prediction. Here house price is the dependent or label or ground truth variable. Let's take the bank loan, whether the person is eligible for the loan or not. If we have that type of information, then only we are able to build machine learning model. Why? Because we will feed X-train and Y-train both to the model. That is the supervised learning and unsupervised learning. So decision tree, what will take, for example, by using one decision tree, we have it gives the class 0. It predicts as a class 0. Instead of using one decision tree, if we have to take in 100 decision tree, 100 decision trees also predicts 100 different classes. So whether might be we have the 4 class problem. So out of the 100 decision trees, there might be 1 or 2 or some 10 trees will go for the overfitting. We will apply pruning also. So if 10, whenever we build a model, 10 tries maybe go for the misleading due to some confusion. Why? Because whenever we build model, every time we won't take same root node. What we are conceptualizing will explain. So how we are selecting based on the 100 trees decision, how we are able to identify the new data point is belongs to class 1, class 2, class 3, class 4 means we will take the 100 decision trees output, we will average. We will average. What will happen if we have the at least we are able to build 70 or 60% good models with good features, good decision nodes. What will do? These 50 or 60 will gives the will predict correctly. Remaining 40 or 30 will predict wrongly. Wrongly, that means out of these 3, for example, we have the 4 classes. Class 2 is the whatever we need to we are expecting. So 60 or 70 decision trees predicts class 2. Remaining 10 predicts class 1, 10 predicts class 2, 10 predicts class 4, like that, due to some misclassification. But whenever we have taken average, what will get the output? That is the class 2. So based on the how many decision trees we form, that many decision trees prediction values average we will take as the final decision. To take a final prediction, we will take the mean or average of the all the decision trees. So then see how, for example, for the we have built 10 decision trees or 100 decision trees. For the 10 or 100 decision trees, we have used same root node every time. Then after same subnodes every time. So if you have built instead of 100, you can build 1,000 trees. But those 1,000 also gives the same output, right? So to eliminating that problem, before going to build decision tree models, we will follow some steps. What are those means? Randomly select k features from the total of m features where k is belongs to m. That means total number of features are, for example, let's assume total number of features are 30. Out of the 30 features, we have taken 10 features to build first decision tree model. Okay. Among the k features, calculate the node d. That is nothing but the root node using the best split point. Then after, split node into daughter nodes using the best split. So by using only those 10 features, we will make one decision tree in these 3 steps. Repeat 1 to 3 steps until L number of nodes has been reached. One number of, sorry, not one number of, sorry, L number of nodes. That means still here, till reaching the leaf node. Then after what we'll do, we'll repeat 1 to 4 again n number of items to create n number of trees. N means that is whether it is 10 or 20, 30, 100, 1000, 1 lakh. That's not a matter. But whenever we go for the another to build the another tree, what we'll do? Whatever the features we used, we selected first 10. Out of the 10, we will take 5 features. Then after we will take what remaining 20, we'll take the other 5 features from the remaining 20. Like that, we will select some features every time, not entire features. So, based on this one, what do you observe? Random forest only, not decision tree. It is also one of the feature selection method also. Why? Because if we have taken entire data set at a time, there might be a chance for the overfitting. At that time, what we need to do? Instead of taking all features at a time, we will take the some amount of features every time. We will make one decision tree. What will happen? For example, one or two features which are not, sometimes there might be chance some other. You can observe people, if we have the 30 features, out of the 30 features, 5, 6 are moreover 10 features. Morely 10 features only doesn't have that much variation. But remaining 20 features definitely will have the information. Why? Because no feature doesn't have any information. We can't build whatever the model we use, we can't build any good model. So whenever we build based on these 10, 20 features which are useful, we will build mostly 50 decision trees. By using remaining 20 features, we will build some other 20 or 30 decision trees. But we have built, why? Because out of if we have the 100 or 200 features also, mostly 70% features are definitely dominant features. Some other 30% or 20% features may be irrelevant or redundant features will be available. So, whenever we select like that, definitely we will build 70 or 7 decision trees or good decision trees based on the good features. Remaining 3 or 30 decision trees will, and maybe there is a chance to mislead the if the irrelevant features is presented in the data set. So this is the process we are building random forest. That's why by using different features, we are building different decision trees. That's why average of these decision trees, average value will be, there might be chance to be as a accurate value. So this is the random classifier structure. We'll take the X data set. Then of this X data set, we'll split first, whenever we build first decision tree, we'll take some n1 number of features. Whenever we build second decision tree, we'll take the some other n2 features, n3, n4. How many decision trees we want to build, we'll select that many subsets, that many times we will subset the features. But don't think whatever the features used in the n1, we won't use this n2. No. If we have, for example, in n1 features, have the 10 features, in N2, while selecting N2, it will take 5 features from the what we already selected for the N1 decision tree and remaining 5 features from the remaining dataset. What we did not consider in the N1 decision tree. Like that, okay? It will randomly select some number of features. So some features will repeat it at least 50% decision trees based on that one. So then based on the average, we are able to which class get the majority voting from the decision tree, will say that data point is belongs to that category, that class R. That is the final class. You people know every model will have some advantages and disadvantages. Whatever the model, everyone have the some advantages, disadvantages. Based on the advantages, disadvantages, based on the problem we are facing, we need to select. We need to build model. We need to change our models every time to get the good accuracy. So here main thing is the accuracy. It's not matter whatever machine learning model you are using to build model to solve the case study, but how much accuracy you are getting. Uh, that accuracy is whether that accuracy is consistent whenever we provide test data or not. That is the main thing. You achieved 90% accuracy, but it's not constant. It will vary whenever we get the new data set. It gives the 90%, sometimes it gives the 70%, 80% sometimes. That means that's not a good model. Consistency also very important on the test data. The model accuracy don't need to change that much. For example, we got the training accuracy 90%, but the testing accuracy varies from 97 to 93. Sorry, 87 to 93. That might be acceptable. Some customers will accept 90, 86 to 94 or 85 to 95. That's the another based on the client's requirement, based on the client's conditions, his expectation. Feature selection with random forest. I already told you, random forest we will use some features for the today to make a decision tree. So random forest algorithm can be used for feature selection process. Why? Because this algorithm can be used to rank importance of variables in a regression or classification problem. Here it says random forest give the rank for the importance of variable. But how do random forest know whether this feature is important or not? How means, for example, it makes first decision tree, it will calculate the accuracy. Then after it will make another decision tree, it will calculate the accuracy. Then after it will make another decision tree, then after it calculate the accuracy. For example, out of these three models, decision tree 2, this one, second one gives the high accuracy compared to 1 and 3. That means the features which are used to make second decision tree, those are the important features. That means those features have the high information and high variation. Here variance is different from the variation. Variation is nothing but information. Variance is that is nothing but that is another one. That is the randomness. Randomness. Randomness means sudden fluctuation of the up, sudden fluctuation of the down, some sudden changes in the data set. Those will become variance. Variance is different from variation. So based on that decision tree more accuracy, it will say these features are important features. Like this, it will give rank for the importance features. So we measure the variable importance in the dataset by fitting random forest algorithm the data. During the fitting process, the out of bag error for each data point is recorded and averaged over the forest. Out of bag error is you people already know. Whenever we build model, it gives the 90% accuracy. That means remaining 10% there might be chance a error. That is the from the each decision tree we will get some error. That's why we will take average of over the forest. The importance of jth feature was measured after training. After training only we will measure. The value of jth feature were permuted among the training data and out of bag error was again computed on this dataset. Sorry, part dataset something. The importance score. This is what I said. It will do the first way for using jth feature. It will build one training model. It will calculate the error. Again, computed this one. Again, importance score of the jth is computed by the averaging difference of the out of bag error. For example, it will take, for example, jth feature is presented in these 3 decision trees. It will calculate the average of it will, if we want to calculate particular feature importance, what we'll do, we will take the accuracy of the all the decision trees wherever that feature presented, and it will calculate the all the error. It will take the average of error and average of accuracy. We need to check error is less and accuracy will be more, like that. Features which produce large values for the score are ranked for the more important than features which produce small values. Small values means small bag of error. So based on this score, we will choose the most important features and we will drop some features doesn't have that much important. Okay. Yeah. Next, coming to the difference between the random forest and decision tree. We are using same, what is the concept we used for the decision tree, same thing on the random forest. But what is the difference between the random forest and decision tree? I think you people, you already know till now. Decision tree means we are building only one tree. Wherever random forest builds multiple number of decision trees. So decision tree, here we are building only one tree. So computationally, if we have calculate one root node, so then after some nodes, it will take 10 seconds or 1 second. If we want to build that many 10 decision trees or 100 decision trees, how much mathematical expressions we need to execute? So it will automatically take some computational slowness. Performance will become slow. Just like decision tree may be due to this one, maybe decision tree suffer with the overfitting. But if it takes random time, random forest to build different many number of decision trees, it takes some time. But this random forest doesn't affect with the overfitting problem. Those are the same differences. See, random forest is set of multiple decision trees. Wherever decision tree have only one decision tree, but random forest have the multiple decision trees. Decision tree are computationally faster as compared to random forest. Why? Because here we are building only one tree, but here we need to build at least 10 to 100 decision trees. If it takes 1 second to build one decision tree, it takes at least 5 seconds to build 10 decision trees. Why I'm saying 5 seconds means in random forest there might be some trees will build parallelly. That's why it won't take that much 10 seconds, but it takes maybe at least 5 seconds. Let's say decision tree may suffer from overfitting. But random forest prevents overfitting by creating trees or random forest. It will take the average. Whichever class have the major voting, that class is the final class. Random forest is difficulty to interpret, but decision tree is easily interpretable and can be converted to rules. Random forest, if we want to interpret means we want to use in any application, what will happen? Whenever we random forest, for example, in an application, if we want to use any model, there might be input of the one model is from the some other backend point. Based on the output, what is we will get from the random forest, this some other computational, some other applications will depends on this random forest output. If the random forest is very slow, what will happen? The entire application will performance will become slow. Why? Because let's take the semantic search. Semantic search. What we need to do? For example, here whenever we type something random forest, how it will suggest these things? Hmm? It will take random. It will give this word to the model. Then after, based on the whatever the output model will give, based on that we need to suggest this one. Why? Because this random belongs to this group. It predicts the random group. So it will filter the whatever the words random have, it will gives here. If the prediction of class will become very slowly, the suggestions will be also become slowly. Is it right? Same thing, same problem. while interpreting random forest into the any application, any project. If instead of a random forest, if we have to take decision tree, performance of decision tree is very less, very high. That means it takes very less time. So, interpreting this decision tree into a particular application, it is very easy. These are the some differences between the random forest and decision tree. Based on our requirement, we need to select whether goes to the decision tree or whether we need to build random forest. Relationship to nearest neighbors. Nearest neighbors means that there is not much. For example, let's take the trees. Whatever the uh, whatever trees characteristics are very near, then we'll say these all trees are belongs to one group. Like that same thing here, it will say the relationship between random forest means K nearest neighbors algorithm was pointed by the. Don't worry, actually we did not completed this K nearest neighbors algorithm. Mostly that section may be tomorrow. After decision tree, it will be K nearest neighbors or some other time series. I don't. Actually, I did not decided. I need to prepare PPT today. Whatever this week, we'll get the K nearest neighbor algorithm. At that time, you people will get that one. Same concept we here. There is no concept. Same. For example, here we take the decision tree. Whatever based on the accuracy. If some other decision tree also gives the same accuracy, what we feel these two are near. If this one decision tree accuracy is 90%, another decision tree accuracy is the 80%. So those are too far. That is the concept behind this one. Whatever the to eliminating that problem, what we'll take the major voting class. Which class got the high votings from the decision tree will finalize, that is the final predicted class. Okay, this is the random forest concept. If you people have any doubts, please unmute yourself, you can ask.
So, ma'am, we can say that this random forest is a part of the decision tree, or it's both are separately the different concepts. Means we have different applications.
Actually, based on the concept, we don't have any different applications. But let's see. For example, if the in application we need to performance is the biggest matter, and at that time what we'll do the decision tree. We'll apply some pruning to get the good accuracy on the training testing data. We'll interpret that decision tree algorithm into the application. But sometimes we are not using for the application model. Internally, we need something. For example, let's take the logo detection or any other classification problem. Here, based on this, for example, we are getting the lot of different documents, but those documents belongs to different groups. But we need to store the documents based on the domain or based on the label. Then at that time, we will use random forest. Why? Because we don't to clumps one document into the another group at that time. So based on the situation, we will select whether we need to go for the random forest decision tree. What is the problem with the decision tree? That is the overfitting. If we are not facing any overfitting while building decision tree, we won't go for the random forest. If we are facing any overfitting problem while building decision tree, then only we will go for the random forest. At that time, we need to say we are using random forest. We need to say to the client, as sir, by using this decision tree model, we are facing lot of overfitting problem. Due to that, we are not able to predict. We are not able to correctly predict on your test data. That's why if you people able to bear some time, that is the some performance, we will build random forest. It gives the good results on the test data. If client accepts, you can go for the random forest. Here, there is you people don't feel. For example, for the pharmaceutical, for some case study, these model only works. There is no model for the particular application. For example, NLP means whatever the different case studies on NLP, we will use same concept for the all case study. For example, if we want to build a house price prediction, Is there no particular model to predict the house price prediction? But you need to check all models: linear regression, decision tree regression, random forest regression, k nearest neighbors regression, SVM regression. Whichever model gives the high accuracy on the train and test data, we need to go for that data, that model. Based on the data, you first build decision tree. If it you did not observe any, why? Because why I'm saying first decision tree, performance wise and interpretability wise, a decision tree is the best. Yes. First, performance also one of the parameter while building models, while building any product. So that's why first you need to build decision tree, and you need to apply some pruning on the decision tree. If your model is won't affect with the overfitting, it gives the good results on the train data, test data, you don't go for the random forest. Whenever you are not able to build good model with decision tree concept or building decision tree model, you changed a lot of you applied some standardization method, normalization method, PCA method, everything, but you are not able to avoid overfitting. At that time only you go for the random forest. Yes, that's it. Let's come to the libraries. You already familiar with these libraries, pandas and these visualization libraries, Seaborn, Matplotlib. This one I think. 1700 records are there. Why? Because same data set I am using what I used for the decision tree. That's why these already we already discussed on the while building decision tree model.
Yes.
Yeah. See, actually we have the two types. Actually, mostly we will use this one. DF describe. See, it gives the count, unique, top frequency, same, mid, high, low, very high. Everything here also. Based on the class. For example, buying have the very high, high, mid categories, low category. Again, main also have the four categories. Doors have the three categories. No, four, two, three, four, five or more. Like this. A count. For example, out of 1728 records, how many records belongs to very high, how many records belongs to high, like that. If you want to see based on the category, how many records we have. This is the class variable. Class variable, target variable, or labeling variable, dependent variable, everything. Here we are assigning input data into the X variable and output data into the Y variable. Then after we need to split data to perform the model accuracy. If we want to see how many records are available, train data, how many records are available, test data. I already told you we need to encode data. Why? Because we need actually we need, if we want to build any algorithm, we need to apply some mathematical expressions. For that let's take the NLP problem. For the NLP problem, we are, guys, am I audible?
Yes, ma'am.
Yeah. Let's take the NLP problem. At that time, what we need to do, if we want to classify documents, every document is in the letters, English letters. There is no chance to be a numeric value. At the time also, we need to convert that each and every word into the vector format. Why? Because if we want to do any uh, computational expression, we want to do any mathematical expression, we need to convert into the numerical data. For that purpose, we are encoding that one. Whatever the category first we identify, we'll give one for that category, two for the next category, three for the another category. Like that, we have one library that is the category encoders. So at the time, you people don't think it gives the high priority for the very high compared to high. But these are the we are here we are changing the value of this one. Instead of very high, we are giving the one, but we are not converting this buying data. Buying variable type is the numeric. This is always object. This is always object. That is the, it consider if we, whether it is the object, it consider it is the categorical data. Whenever we convert that feature type is into the int or float, then will it consider it as the numeric data. So here sklearn we are saying the random forest, for the forest, what we are doing, we are fitting the x train and y train. Then after we are predicting expect y predictions by using the x test input variable. Then after we are providing the y test and y pred to calculate the accuracy. That is the 94%.
I mean, when we have seen the decision tree, in that also we were getting like same, right, above 90% accuracy.
That means this data, due to this data, we are not affecting overfitting for the decision model also. No, 80%.
Okay.
80 and 78. 78 on the training data, 80% on the testing data. But whenever we use the random forest, we got the 94%. Yeah, here we did not specify any how many number of decision trees we want to build, but we have that feature as, also, that is the n estimators. Here you can give any number of values, that many decision trees it will be built. I'm giving 50. Why? Because 100 maybe it takes some time. I don't know how much time it takes for the 50. Yeah, same 94% accuracy we got that. So just this is for example, let's take to build decision tree, it will take some time. So for example, if we are able to get good accuracy for the 10 decision trees, we don't need to build 100 decision trees. So let's take, I have taken 10 decision trees, it gives the 92% accuracy. If I have taken 50, how much does it have? 94. Let's take the 100, 94. Let's take the 500, 94. That means 50 is enough. No need to build 100 or 500 decision trees. Why? Because we are able to get 94% accuracy with 50 features. Till if we use the 100 or 500,000, it gives only 94% accuracy. But let's say there might be some time difference. Whenever I want to build 50 features, it gives accuracy 94%. Whenever to build, 500, what happens? It takes some time. Yes. So by using this model, if we want to predict new data point, it maybe takes some time. But if we use 500, if we instead of 500, if we have taken 50, then whenever we go for the prediction also, it will predict within less time. So like that, we need to give number of estimators. Okay.
Okay.
See, how to find importance features importance through the random forest. For that one, I am giving the 100 features. Here we have the feature scores, PD random forest, CLF. CLF is nothing but the random forest of model. So random forest model we assign to the CLF model. Here we have the some uh, features, feature importance and extend columns, sort values and ascending. So I have sorted like this. See, safety feature have the high importance compared to the remaining features. See, I shared one screen. Their feature scores is the variable I am assigning into the here CLF. Did you people got the whatever I shared image? So you are able to see this group. So this CLF random forest model have a feature importance. If we want to see which features are have high importance, we have that option also. CLF dot feature importance. If you give this variable to the series, it gives the important practice. Let's take the safety have the importance person saying mind logbook doors. These are the high important features. By using build these features, you can build one model. Let's check the accuracy. That's it. You people previously the measures extrained directly. This time you people uh, what are the features? So you people know how to drop unwanted features, how to select only required features. Below this one is the confusion matrix. So it is in confusion matrix what we observe. We will observe precision, recall, and accuracy. For that purpose, what are the terminologies we will use? True positive, true negative, false positive, false negative. True positive means actual value also positive. Our model also predicted as a positive. That is the true positive. True negative means actual value also negative. Our model also predicted as a negative. That means correct predictions. True positive and true negative both are correct predictions. Coming to the false positive. False positive means actual value is the negative. Actual value is the negative. But our model predicts it is a positive. That means falsely predicted it is a positive. Actual value is negative, but our model predicts it is a predict positive. That means falsely our model predict it is a positive. That is the false positive. Coming to the false negative, actual value is the positive. Actual value means whatever the we are expecting it is a positive. But our model predicts it is a negative. That means our model predicts falsely it is a negative. That means the incorrect. It is the class 0 or class 1. That is this false positive is comes under the type 1 error. We consider it is the type 1 error. False negative. That means actual value is positive, but our model falsely predict as a negative. That is the type 2 error. Based on the client requirement, we need to try to reduce the type 1 or type 2 error. Mostly everyone tries to reduce the two types of errors, but sometimes client able to bear somewhat type 2 error instead of type 1 error. What we'll do at the time? We will try to decrease type 1 error, somewhat of increase in the type 2 error. Okay. That means if you people want to say, for example, bank loan, instead of a banker is able to bear instead of predicting wrong who are not eligible for the loan as a eligible for the loan, he won't accept this type of scenario. The people who are not eligible for the loan, if we predicted he is eligible for the loan, he will lose entire money. Instead of this one, what it is bear, it banker will bear to predict who are eligible for the loan, to predict he is not eligible for the loan. So at that time, what will do? Will provide high amount of data which are related to the bank which is not eligible. Wherever we are misclassifying the guy who are not eligible for the loan, we are predicting he is eligible for the loan. Which type of data is if by providing which type of data we are not able to this misclassification, will try to feed that type of data compared to other case data. Like this, by increasing one value, we will try to decreasing one error. People, did you got?
Yes, ma'am.
Yeah, yeah. That is the confusion matrix. Then after, uh, let's check the. I provided the classification report also. I provided some references link. These references links, when will we useful these references mean? whenever we build real time project, at the time, if we actually, I'm saying each and everything, how to handle everything. But after 6 months or 4 months, you are really got the work to build the random forest model. At that time, there might be a chance to forget some small concept. These references links will be useful to gather again information. If you have any doubts, go for these references links. You will get more information. Okay?
Yes. Yeah.
Yeah. Uh, Anybody have any doubts again? Okay, thank you.